The first thing we should do is to expand the window to make things easier to see. Then from the File menu, choose Load Workflow, navigate to the /workflows directory, and choose Demo Callisto Jupyter to load. Now that we've loaded the workflow, let's click on the Scripting tab to see the widgets in the Scripting drawer, and drag the Python 2 widget onto the canvas. Then let's rename the generic Python widget to CutAdapt. This is the package that we'll be adding to the workflow. Now let's save the workflow with our custom CutAdapt widget. From the File menu, choose Save Workflow As, and type in a new workflow name, Demo Callisto Jupyter CutAdapt. We'll save it as a local directory under the /data mount point. In this way, the new workflow will be saved permanently, even after we quit BWB. Let's choose a color for our new workflow to distinguish it from the old workflow. Then choose Merge All Widget Types and hit OK to save. As you can see, the new workflow is blue, and there's also a new drawer in the tool dock, which contains all the widgets in the new workflow. Although we've changed the name of the Python widget to CutAdapt in the workflow on the canvas, the widget still has its original name in the new workflow drawer. Widgets with different names in the workflow can come from the same definition. For example, one could have different download widgets downloading different files in a workflow, but they still have the same underlying commands and use the same containers to perform the download. However, in this case, we really are going to change the Docker container and the commands and not just parameters, so we really should rename the source widget that resides in the new drawer. This can be done from the widget definition window, which comes up after right-clicking and choosing the Edit Definition option. Clicking on Rename allows us to rename the widget definition. Notice that the name of the widget in the drawer has now changed. Let's also change the description. This is what appears in the help box under the tool dock when you mouse over a widget. Let's also give a name to the Docker image that we will create in the next step. First, we click on the Docker tab. The Docker file for this tutorial has already been prepared. It can be found in the /tutorial files. In the video, I've already copied the tutorial files to a local directory. I can certainly create the Docker container using that Docker file, but it's nicer to have the Docker file in the widget directory in case we'd like to make further modifications later. BWB comes with a built-in tool to build Docker images. After launching the tool, we load the Docker file, which is a set of instructions used by Docker in order to build a container. In this case, we've made some minor additions to the original Python container. We've added a few libraries that are necessary for the CutAdapt script. To use the tool, we enter the image name to be used, choose to use a Docker file instead of a set base image, and then simply hit the Build button. A message shows up in the right-hand corner to indicate that the container has been successfully built. Now comes the task of customizing the widget. Here we specify the inputs and outputs of our widget. These will determine how our widget interacts and connects to other widgets in the workflow. We will also specify which parameters we expect the user to enter. The CutAdapt widget will read in a set of FASTQ files and output the trimmed files to the same directory as the input files. Thus, the output directory of the preceding widget that downloaded the files is the same as the output directory of our CutAdapt widget. So what we want to do is to have the download widget send the name of the output directory to our CutAdapt widget. This will let the CutAdapt widget know where to read and write the files, and also signal that the download widget has finished and that the CutAdapt widget should begin processing. So let's click on the Inputs tab. There are currently two inputs. The first is input file, which is the Python script that is to be run. The second is a trigger input, which can be used to trigger the execution of the CutAdapt widget upon receiving input from another widget. Now let's create a new input variable, output_dir. This will allow another widget to connect to the CutAdapt widget and transfer a value into the variable output_dir. We will also use its input as a trigger, so that CutAdapt will start executing once the previous widget has signaled that it has finished downloading by setting the name of the output directory. Now let's click on the Parameters tab. Next, we add output_dir as a parameter. This allows us to enter a value for output_dir when the input is not connected to another widget. The fields can be edited using the form at the bottom of the text box. We will also need to add two new flags. A -q flag that determines the minimum quality, and a -m flag that determines the minimum read length. These parameters control how much CutAdapt will trim from the FASTQ files. Finally, we need to change the input file from an argument to a flag. Arguments are put at the end of the command, whereas flags are placed in the order which they appear in the text box. The input flag is the Python script, so it needs to appear in the command before any of the other flags. Now let's make one final check to make sure that everything that we've entered is correct. And then hit the Save button in order to save our new CutAdapt widget definition. We're now ready to connect our CutAdapt widget to the workflow. We're going to put it in between the Download FASTQ Files widget and the Callisto Quant widget, since it will be pre-processing the reads before they are pseudo-aligned. So we first get rid of the current link between the Download FASTQ Files widget and the Callisto Quant widget by right-clicking on the link and choosing Remove. Now we connect the Download FASTQ widget. We drag the mouse from the right-hand side of the Download widget to the left-hand side of the CutAdapt widget. A screen shows up that allows us to choose the input to connect that output. So we connect the output dir output of the Download widget to the output dir input of the CutAdapt widget. Now that the Download widget is linked to the CutAdapt widget, to give us a little bit more room, we drag the two widgets to the left of the canvas. Then we connect the output of the CutAdapt widget to the Callisto Quant widget. Here we connect the CutAdapt output dir output to the trigger input of the Callisto Quant widget. Note that the same variable can be both an input and an output. We've now set the workflow up so that once CutAdapt is finished processing, it will send the value of output dir to the trigger of Callisto Quant, which will then begin executing. Now that we have everything connected, we need to enter the CutAdapt parameter values. We double-click on the widget to bring up the UI window. The most important entry for this widget is the name of the custom Python script that is to be run. The script that we have prepared is a simple wrapper that looks in the output directory for FASTQ files and then calls the CutAdapt package to process the reads. We have provided this script in the /tutorial files directory. It must first be copied to a local directory, and then the location of the script is entered into the form, either manually or by using the folder icon to navigate to the file. We can leave the other entries at their default values. However, we do need to enter our execution settings so that the CutAdapt widget will start running once it has received the output directory from the previous download widget. From the Run Mode menu, we choose Triggered, and from the Select Triggers menu, we check off Output dir. The modified pipeline is now ready to run. Let's start the modified workflow by double-clicking on the Download Sleuth Directory widget and clicking on the Start button. We'll also open the new CutAdapt widgets console to see that it is actually processing the reads. It correctly activates the Callisto Quant widget, and the pipeline finishes by popping up a Jupyter notebook with the sleuth results. The user is free to cut and paste those results or modify and rerun the code in the code cells. The same procedure that we have illustrated in the tutorial can be used to add other scripts to further customize the workflow.